Okay, let's try this one. You have x cubed minus x as x times x squared minus 1. And then this also factors as x minus 1 times x plus 1. So that's how you factor the denominator. Once you factor the denominator, you use all the factors of the denominators to build simpler fractions, which will eventually add up to this fraction after making common denominators. So I think for this to happen, you better have a over x. For this to happen, you better have b over x minus 1. And for this to happen, you better have c over x plus 1.
Yeah, we do plus because plus is minus and minus is plus.
Yeah, okay. Yeah, so sometimes you will end up having some of them as minus, but plus is minus.
But we're still in the easy examples right now, so we're going to do plus, right?
No. We're going to do the hard part next, but that's not the hard part, okay? Trust me, the hard one's really hard.
When you work it out, if the number is negative, you'll get a negative.
Yeah. So the number will become negative, that'll work out, yes. Okay, so what do? We're going to use the tip of multiplying this over to the other side so that you get 3x squared minus 4 on the left side. Okay, tell me what you would get after this is multiplied and canceled. A would be multiplied by?
X minus 1, x plus 1.
X minus 1 times x plus 1. B would be multiplied by?
X plus 1.
X plus 1, yes. And then C would be multiplied by x times x minus 1. Okay. And that equation is an identity, meaning that it's an equality between functions. It has to be true for all values of x. Therefore, whatever value we plug in left and right, it should match. So we choose x equals to negative 1? Okay, we choose negative 1 because when negative 1 is plugged into x plus 1, it's going to be 0. So this is going to go away, this is going to go away, and this will become negative 1 times negative 2, which is 2 positive 2c. So you're going to have 2c on the right. This will be 2. On the left side, negative 1 squared is positive 1. 1 times 3 is 3. 3 minus 4 is negative 1. So you get c equals to, it's a little noisy out there, right? C equals to negative 1/2. Okay. And then, what's the next number we plug in? What should we plug in? 1, okay.
1 and negative 1.
Well, we already did the negative 1. Okay, so we plug in 1, and then this time, which one will be 0? How about this one? Will it be 0?
Yeah.
Yeah, 1 minus 1 is 0. How about this one?
Yeah. No.
No. 1 times 2. So that will be 2b on the right side, and then this one will also become 0. 1 minus 1 is 0. And then the left side, again, if you plug in 1, 3 minus 4 is negative 1, so that b will be negative 1/2. Okay. Now, what about x equals to, we got the c, we got the b. What should we plug in now? X equals to
We don't need to plug it in.
0. Yeah, 0. Because then anything that has x by itself will become 0, right? So 0, 0, and this one will be negative a. And then when you plug in 0 here, you get negative 4. So that a must be positive 4. Okay. So you're pretty close. We have this equal to 4 over x, and then negative 1/2, so it's like negative 1/2 of x minus 1. See how it fixed itself? I originally claimed plus, but it later turned out to be minus because that coefficient is negative 1/2, right? And then minus 1/2 over x plus 1. that means integrating this the same as integrating this, and that means it's 4 times 1 over x integrated, you get ln of x, minus 1/2, and then it's 1 over x minus 1. That integrates to ln of absolute value of x minus 1. And then negative 1/2 comes out, and you get ln of absolute value of x plus 1 plus c. Done. That's the answer.